In section 4.1, I'm going to review the trigonometry that's necessary for you to know to complete Physics 1. On to higher dimensions. Prior to this, we've been working with vectors. Vectors are quantities that have a direction as well as an amount or magnitude. And up until now, we've only been working with vectors in one dimension. And in one dimension, we can answer questions about vector addition quite easily. We just have to keep track of the directions with a positive or negative sign. For example, if we move 4 meters forward, we can make that 4 meters forward the positive direction. And then if we move 3 meters back, we can add those two to get +1, which means that our net motion is 1 meter forward. But if we try to do something similar where we have to move in two dimensions, the forward direction and the right left direction, well, now it becomes a bit more complicated. And you'll notice that we're representing vectors with arrows. So we can move 4 meters forward, and then if we turn to the right, we'll move another 3 meters. Well, our overall motion is from where the blue arrow started to where the red arrow ended. So it'll look something like that. And you might notice that what I have drawn here is a right triangle. And this is a special right triangle. It is the famous 3, 4, 5 triangle. So we know that we moved 5 meters, and we can use a little bit more trig to determine the direction that we moved. You can actually work out this angle. This angle works out to be 37 degrees. So we moved 5 meters in a direction that's 37 degrees, rotated to the right from where we were walking forward. So you may have noticed that when we have two-dimensional motion, we have to utilize trig. So we're going to review the trigonometry that we're going to use for the rest of the year when we have to add and subtract vector quantities in two dimensions. So in physics, we choose the Greek letter theta to represent angle. You can really use any letter to represent an angle, but we prefer to use theta. And when we have a right triangle, we can describe the angle with the x-axis, or we can describe the angle with the y-axis. The hypotenuse of a right triangle is the side of the triangle that is opposite to the right angle. So when I use this word opposite, I'm referring to a side that does not make up the angle. This is the right angle, and the longest side right here, the hypotenuse, is what is the side that is opposite that right angle. Generally, we're going to work with the angle with the x-axis, theta x. And when we are working with that particular angle, that side is the opposite side, and that side is adjacent. Adjacent means next to. So the adjacent side is the side that makes up the angle along with the hypotenuse. Now, generally, we're going to work with the angle with the x, but sometimes we might have to work with the angle with the y. And in that case, the way that we describe the legs, the opposite and adjacent sides of the triangle, they're going to swap with each other. Okay. Generally, we use the angle with the x, but we sometimes it will use the angle with the y when it is more convenient. Now, there's some basic trig formulas that you should remember from math class. The first is what's known as the Pythagorean theorem, and that relates the three lengths of the three sides. A squared plus b squared is c squared. Now, when you use this, it is absolutely important that you always label side C as the hypotenuse. So if we have a triangle, we can call this side C, we can call this side A and B, or we can do, if this is the same triangle, this side is C, and we could flip-flop are A and B. It doesn't matter which side is A and B as long as the hypotenuse is side C. We should also remember that angles theta x and theta y are complementary, which means that they add up to 90 degrees. And we know that that's true because the three angles in a triangle have to add up to 180. And we already know, since we're talking about right angles, that one angle is 90 degrees. And so the other two angles, theta x and theta y, have to add up to the other 90 degrees to make the total 180. The three basic trig functions, sine, cosine, and tangent, operate on angles to give you the ratio between two sides of a right triangle. And the utility of the trig functions come in when you know one angle and one side length. You can then set up an equation with the trig functions to find an unknown length. Here are their definitions. The sine of an angle is the opposite side to that angle over the hypotenuse. The cosine of an angle is the adjacent side to that angle over the hypotenuse. And the tangent of an angle is the opposite side to that angle over the adjacent side to that angle. And we should remember that which sides we regard as opposite and adjacent depend on which angle we're working with. There's this common mnemonic, SOHCAHTOA, that can help you remember the trig functions, but I will put these three definitions on the equation sheet, so you don't really have to remember them. In this example, we're given a right triangle where we have to find the missing angle and the two missing sides. We can start out by finding the missing angle. We know that the two angles have to be complementary and add up to 90 degrees, so we can write an equation. The known angle, 30 degrees, plus the unknown angle, theta y, have to add to 90 degrees. And so theta y has to be 60 degrees. Okay. When solving for one of the sides, you're going to have to use a trig function. Now, when selecting a trig function to set up an equation, we need to choose an angle to work with. I'll choose to work with the angle 30 degrees. When I select that angle, this side is the adjacent side, and then side y would become the opposite side. And so now I can use a trig function along with the hypotenuse. So I'll start off by solving for side y. Side y is opposite to the angle I'm working with. And the 16 meters is the length of the hypotenuse. So I want to select the trig function that relates the opposite side to the hypotenuse, and that's sine. So I can write the sine of 30 degrees is equal to my unknown side, which is side y, over the hypotenuse, which I know is 16 meters. Okay. I want to point out that the sine of 30 degrees is a number. Okay, you can treat it just like any other number, and it actually works out to be a nice number here because the sine of 30 degrees is exactly 1/2. Okay, in solving for side y is then going to be half of 16 meters. So side y has a length of 8 meters. Okay, again, we're going to have to choose a trig function to solve for side x. Once we know two sides, we can use the Pythagorean theorem, but I want a little bit more practice using the trig functions. So I need a trig function that relates the adjacent side to the hypotenuse, and that's cosine. So the cosine of my 30-degree angle has to be the adjacent side, which is side x, divided by the hypotenuse, which is 16 meters in length. Okay? And again, cosine of 30 degrees is just a number, and we can do math and algebra with it just like we do math and algebra with regular numbers. And so we can multiply both sides by 16 meters to get x by itself. So 16 meters times the cosine of 30 degrees is going to give us our answer, 13.9 meters. Okay. Something that is a useful little check once we've solved for all the sides. Theta y is the larger angle, And so the side that's opposite theta y, which is side x, should be the longer of the two legs. And you see that that is so. That side x is longer than side y. Okay, one more example, and this one will be similar to the last one. Here we have to solve for the missing angle and the two missing sides. Again, we'll start off by finding the missing angle. That's a little bit easier because we know that the two angles, theta x and the angle that we know, 53 degrees, have to add up to 90 degrees. They're complementary. And so we can subtract 53 from 90, and that gets us our missing angle, 37 degrees for theta x. To solve for the side, we're going to have to set up a trig function. Again, we have to choose one angle to work with. I'll choose the given angle, 53 degrees. And if that's the angle we're working with, the 4 inches is the opposite side, and side y is going to be the adjacent side. And so now I have to choose a trig function that relates the opposite side of the angle to the adjacent unknown side, and that is tangent. The tangent of my angle 53 degrees will be the opposite side, which is 4 inches, over the adjacent side, which is my unknown side, y. And again, tangent of 53 degrees, it looks like a complicated thing, but this is just a number. You can do algebra with it just as you normally would. Quick algebra shortcut, if I'm solving for the denominator, the other side's just a number, which it is, I can just trade those two. And so y is going to be 4 divided by the tangent of 53 degrees, which gives us 3, and this will be in units of inches. To solve for side h, the hypotenuse of the right triangle, we have to choose a trig function that relates one of the known sides, and now we know two of the legs. I'll choose the opposite side, which is 4 inches, and the hypotenuse, and that is sine. Sine relates the opposite side, which is 4 inches, over the unknown side, which I want to find side h. Again, I can do the same kind of algebra. I'm solving for the denominator. Left-hand side is just a number, and so I can trade those two. And so the hypotenuse is going to be 4 divided by the sine of 53 degrees, and that's going to give you 5 inches. This is the famous 3, 4, 5 triangle. Okay, so what if you need to find an angle? If we're not told one of the angles, how would you find it? Well, if you know two of the sides, then you can use the inverse trig functions to find the angle. The inverse trig functions operate on a ratio. So if you know two of the sides, you can find their ratio, and it outputs an angle. So we can use the trig functions to find that angle if you have two sides. Okay? It's important to note that the inverse trig functions undo the trig functions in the same way that inverse functions always undo their functions. So for example, if we have square root of x, well, what's the inverse function to the square root function? Well, that's squaring. If we square the square root of x, squaring undoes the square root, and then we just get x. In the same way, if we had sine of x and we wanted to solve this expression for x, well, then we would have to undo sine. Well, what undoes sine? Inverse sine undoes sine, and out would just come x. So we're going to use that in this example because here we are given two sides, but we don't know any of the angles. So we'll start with the unknown side. If we know two sides of the triangle, then we can use the Pythagorean theorem to find the third side. And we can set that up like this. The Pythagorean theorem says a squared plus b squared is equal to c squared. Doesn't matter which side is a and b, just as long as the hypotenuse, side h, is side c. So we can say 8 squared plus 15 squared is h squared. From here, we can square both terms here. Add them together. And then take the square root of both sides to give us side h. And it works out that side h is 17, and the units for this are going to be meters per second. So you might say to yourself, well, meters per second, isn't that a unit for speed and not length? Well, as you saw before, we can use arrows to represent vectors. And when we arrange two arrows representing vectors into a diagram, they always form a triangle. So we can actually use triangles to represent things that aren't lengths. We can use the length to represent how fast something's going or how quickly it's accelerating. Okay, for the angles, we have to choose one angle to solve for. So we'll choose side theta x, and we know the opposite side, the 8 meters per second squared, would make up the opposite side, and the 15 meters per second, that would be the adjacent side. So which trig function relates the opposite and adjacent sides of a triangle? That's tangent. So the tangent of my unknown angle has to be the opposite side, which here is 8, over the adjacent side, which is 15. And so now I have to undo the tangent function to get theta x by itself. So if I take the inverse tangent of both sides, left-hand side will become theta x. Inverse tangent undoes tangent. And then over here, we'll have inverse tangent of 8 over 15. And when I punch that into my calculator, that will give me the angle. That's 28 degrees. Okay. Now, to solve for theta y, yes, I could just subtract 28 degrees from 90 degrees. That would be the quickest and probably easiest way to do it. But to get a little bit more practice with the inverse trig functions, let's complicate it a little bit. If we're solving for theta y, well, now the adjacent and opposite sides flip-flop. And we can use, again, tangent, but now it's not going to be 8 over 15. Now it's going to be 15 over 8. We have to undo the tangent function. We do that by applying inverse tangent to both sides of the equation. And theta y is going to work out to be 62 degrees. And it's a nice little check that theta x and theta y both add up to 90 degrees. That's because the two angles in a right triangle are complementary.